Okay, this is the inductance L, and this is 2L. So we have a switch. So this is the switch is at initially position 1. So any current will flow in the circuit. So let it be I naught. And it is at steady state. So what is I naught? I naught should be equal to E by R. Now the switch is suddenly moved from position 1 to position 2. Now find the current in circuit as a function of time. This is a resistor R. This is the inductance 2L. This L. This is at t equals 0. I am drawing this circuit. After some time t will come later on. The moment I move the switch from position 1 to 2, that instant of time is what? T equals 0. What will happen here? We have to analyze here first what conditions will prevail here. Then I know, okay, this is the initial current flowing, then I'll proceed further, the writing equations. Now there was a flux, no? There's a flux. Now when you move the switch from 1 to 2, then this inductance will get added up to the circuit, no, here, and that will be added up in series. So what happened to the flux? Flux cannot change abruptly, no. So what all this flux is there? Flux linking the coil shouldn't. So it will be like this. The same flux, amount of flux will be shared by both. What all flux was present, that will be shared by both here. So here I'll call this flux as phi, and that flux let me we are doing some, you can say almost some loss will be there. When you the moment you move switch from 1 to 2 open, there'll be some loss. We are doing, you can say, almost like a ideal case. What was the flux in the coil 1? Now the flux what happened will be shared by both, and the flux what happened should be conserved here. So what was the initial flux? L into I naught. Now what will happen? A current will flow. I'll call that as I naught, we chosen symbol, no? Find the current, any symbol. Let me write. Small I naught, I'll write it. Again, you'll confuse. I1, I'll write it. No problem. Okay, I1. I'll go for I naught. So this should be equal to how much? Flux linking. This will be L into I naught plus 2L into I naught. You have to show that I naught here also. L get cancelled. So therefore that I naught should be equal to I naught by 3, or I naught is equal to E by. So this much of current will be flowing initially. Then after any instant of time, current, let it be I. So what is the expression for current? But you should take care that initial conditions, no? So write down the equation for this. So this will be plus minus plus C minus IR minus 3L di by dt. Shall I add up? They are in series, equal to 0. Then in the limits you put at t equals 0, the initial current is I naught, and get expression for current at any time t. So this, after solving, we'll get this is E minus IR equal to 3L di by dt. E by R minus I is equal to 3L by R di by dt, or di is equal to E by R minus I dt by 3L by R. Here you substitute that at t equals 0, what was the current? I naught. At any time, let it be I. Later on, as we learn mutual inductance, and there's a slowly some problems I'm introducing. Later on, we'll learn mutual inductance. There you can see that. So what happens if I bring parallel? Things are a little bit very complicated. Now, solve this. This will be log of E by R, I by minus T by 3L by R. Okay, simplification of this will be E by R minus I is equal to E by R minus I naught e to power of minus lambda, I'll write it. So where lambda is time constant of circuit, 3L by R. Now this further simplification of this will be E by R minus E by R minus I naught. Now what is I naught value? E by 3R. Two E by 3R. So this will be, we can't take it.
Minus di by dt.
What happened?
Current will decrease, will take minus. From where did you get minus signs?
Due to integration, no?
Yes, sir.
So this is the expression for the current in the circuit here, no? Okay, so you have to just suddenly when you bring, say, like a capacitor connected to another capacitor, these are things. So here what happened, the charge of two plates were considered, no, similar, the the idea of flux will come into picture. I don't think so in advance they'll go for any very complex situation, because if I bring another inductor parallel, no, things are very complicated. It's not that easy the way we are thinking. One of the simple cases is what we have information here. Slowly when we learn series parallel, you get some basic picture. So this, I think the overall concept, flux linking the coils remains constant. Means the flux is conserved. I'll write it nearby here. Nearby question, I'll write it. Flux is conserved.